Which of these isomers of pentane has the highest melting point? Well, if you look at them all, of course, they have the same number of carbons and hydrogens, so that's not a factor. But this N-pentane here is more linear and a rod-like structure. It's long, so it's going to have the highest surface area. Highest surface area is going to correspond with the strongest dispersion forces. So that sounds like a good candidate, but let's look at the other ones. Over here for B, we have neopentane, and this is the most compact. It's kind of spherical in nature. And so this is going to have the lowest surface area. And then over here we have isopentane, which is somewhere in between them, right? But the way that I like to think about this problem, although I asked her what's the highest melting point, I prefer to think of it from the viewpoint of which one has the highest freezing point. Now, it's the same thing, melting and freezing point, but when I think of the highest melting point, I think about them all being solids, and as I raise the temperature, which one is going to melt last? But when I think about the highest freezing point, I think about them all being liquids, and I'm cooling the temperature down, and which one's going to freeze first. And to me, that makes this easier to think about. And so if I look at N-pentane, although it has the strongest dispersion forces, it having this structure makes it kind of like having a bunch of worms in a bucket. And so imagining that trying to form a repeatable structure to form a crystal, a solid, seems kind of like a feat. Like you're going to really have to cool it down so that they get into this organized fashion where they cannot escape each other's intermolecular forces. And so that they're rigidly stuck there, right? But then I look at neopentane, and that being spherical, it's like having golf balls in a bucket. So it's already probably relatively organized as a liquid. And so when I cool it down, I imagine it being easier, meaning it would freeze earlier as I cool it. And then I look at the last one over here, isopentane, and it's kind of like the worst of both worlds here because it's kind of long like the N-pentane, but it's also asymmetrical because of that methyl group. So I imagine that interrupting the lattice formation because it's just kind of wonky shaped, right? And so I'm going to give you the temperatures that each of these freeze at. But guys, if these videos help, please give a like, follow, share, save. And thank you to my patrons. And if you guys want to support the channel, you can do that right here. But if we look at the freezing points of each of them, the N-pentane freezes at about -130, the neopentane at -16, and the isopentane at -160. So when we think about it from the viewpoint of which one freezes earlier, the packing efficiency and the orderliness that they can form a crystal is critical. And so that's why neopentane is our answer. That freezes first at -16. Guys, if I had asked you which one has the highest boiling point, what would your answer have been? Comment down below, and I'll see you in the next one.